Hey class, this is notes for sheet number 6. Single displacement is a type of reaction. Now take a look at what this reaction looks like. Here we have A. A is, for the most part, A is typically going to be a metal, and this metal is going to kick out the positive part of the compound. So we have a metal plus, I should say, we have an element plus a compound, and that's how we can identify that it's a single displacement reaction. Most times that's going to be a metal for the element, and it's going to kick out the first part of the compound that's positive. So the B is positive and the C is negative. Okay, so notice what happens on the other side. A kicks out B, so you have A positive, C negative, and then B's by itself. But this only happens in certain situations. Not all single displacement reactions work. It actually happens when, and we need the activity series for this, when a more reactive metal kicks out the positive part or the cation of the compound. A more reactive. Now what does that mean to be more reactive? When we take a look at the activity series here, that means that the lower the number, the more reactive, so these are the most reactive metals, and these are the least reactive metals. So a lower number kicks out a higher number. Okay, so let's see exactly what that looks like. So here it says each metal in the activity series displaces any metal below it from a salt solution. So that means that if I take a look for iron and copper, because those are the two that I'm comparing, iron is right here at 12 and copper is over here at 22. So if this is 12 and this is 22, each metal in the activity series displaces any metal below it. Copper is definitely below iron in the activity series. That means copper is less reactive, which means that iron can sure kick copper out of the compound with sulfate. But when we go from one side to the other, we have to go back to symbols and charges. So iron here goes back to, now, here's the thing. Do you remember iron on the periodic table? What does it look like? Periodic table for iron has the dotted line. It has Fe with a +3, and it says iron 3, and then Fe with a +2 below, and it says iron 2, like that. So we're going to use the top one because it's the most common, so that's a +3, like that. SO4 has a -2 because that's what it always has, and plus, and now here's the part that's by itself now. By itself means that it's left without a compound. There's no charge here, and there's no Brinkelhoff for copper, so we can just leave it as Cu. Now once I do this, I have to go back, like with all of my, whenever I write new products down, I have to crisscross. So that means Fe2 SO4 parentheses 3, and then I can get rid of the charges. Okay? Now once I have the products written down, let me just get rid of some of this stuff here. Once I have the products written down, now I need to go back and balance. Notice I have 3 SO4s, which means I'm going to need 3 SO4s there. I have 2 Fe's on the right-hand side, which means I need 2 on the left-hand side. Notice the 3 in front of the SO4, the CuSO4, means I have 3 Cus and 3 SO4s, so I need 3 Cus on the right-hand side, and that should be balanced. Now notice what happens here when I try to use iron again, but in this case though, in this case iron is still at 12, but now I go take a look at aluminum, and aluminum is right here at number 8. Now aluminum is more reactive than iron is, so this is actually going to be a no reaction, which means you don't have to do any crisscross, you don't have to worry about Brinkelhoff, you just put the NR for no reaction. Okay, I'm going to do one more type of notes for letter B, and then we'll take a break, and then you'll have another screencast for the C and D. So take a look at the next one then. This is a metal and an acid. Now the only difference that's about the metal and the acid, it is exactly the same thing. This is still A plus BC yields AC plus B. Exactly the same. The only difference is that this part right here is an acid, and the only difference that makes is that hydrogen, if you take a look on the activity series, back here is always number 8. So I'm going to get rid of these arrows and stuff, and you can see there's hydrogen. So any of those that are above hydrogen, from lithium onto lead, from 1 to 17, are going to react with acid, and those that are below, antimony down to gold, will not react with acid. That's the only difference. So it doesn't mean really anything different. So zinc, I forgot to check where zinc is. Where's zinc? Zinc's number 10. So zinc at number 10 is going to react with acid. So that means I go back to symbols and charges. So that's zinc with a +2. And this right here, that's my B, that's my C. So A here kicks hydrogen out and reacts with C, which is Cl with a -1. Okay? And then hydrogen is by itself, or any of these that react with acid, is going to give us H2, because that's part of Brinkelhoff. And that's where the 2 comes from Brinkelhoff. So here I go back to symbols and charges, and I crisscross the ZnCl2. Okay? And I get rid of the charges then. Then I come back and I just have to balance the equation with a 2 in front of the HCl and a 1 in front of everything else. And now that is balanced. So take a look at what happens. Here's another case where I have magnesium is 7. Take a look at it. There's magnesium at 7. Definitely less than 18. Remember, hydrogen's always 18. So it kicks out hydrogen. So that means that the A comes here, kicks out B, and goes with C. So Mg has a +2 because it's in the second group, and they all have a +2. SO4 has a -2, and then hydrogen's by itself, but because of Brinkelhoff, I put the 2 there. These +2 and -2 cancel, so that's all I have to do for that. And then I check to see if I got 1 magnesium, 2 hydrogens, 1 SO4, and 1 SO4. So that's balanced. So is there another example here? I think there is. Take a look when platinum. What's platinum? I think platinum is like 25 or 26, maybe even 27, I don't know. Whatever it is, well, let's take a look back. 27, it's 27. So 27 is definitely less reactive than 18. So this does not work. This would be a situation of a no reaction. All right, stay tuned for parts C and D.